Well, good afternoon or good morning to you, wherever you are. Thank you very much for joining us. Come on into the webinar. My name is Fraser Chesterman. Whilst we let people join us, I'll just introduce everyone and explain what we're doing today. This webinar will run for around an hour or so. Probably the presentation will be about 45 minutes. And we're focusing very much on accelerating deployment of high-performance end-to-end PDF workflows for digital inkjet applications. And I have two amazing speakers with me today. So very pleased to have with me Mark Lewicki of Adobe and Simon Edwards of Global Inkjet Systems. I'll get you both to introduce yourselves in a moment. The subject for today, really what we're talking about is the way in which, as we all know, inkjet technology has opened doors in lots of different applications. Particular markets we know about: packaging, textile, product decoration. But clearly every job that we're looking at has a design involved. There's something that you're actually printing. So there is a design which needs to pass through a series of transformations, and upstream software and hardware is key to capitalizing on that full potential of that digital print system, and of course of delighting your customers. So this particular webinar is really going to look at how to guarantee the best of success with your high performance systems. And as I said, I have two great guests with me. I'm going to get them to introduce themselves. Firstly, Mark Lewicki from Adobe. Introduce yourself, please, Mark.
Hi, I'm Mark Lewicki. I'm the Senior Product Manager for the Adobe PDF Print Engine, which is our flagship product for commercial printing. It's the basic successor to our PostScript technology, our founding technology, and used today in workflows, print workflows in all segments around the world. Fantastic.
Thanks, Mark. And I have Simon Edwards with me, who's Business Manager at Global Inkjet Systems. Simon, welcome to you.
Thanks, Fraser. Really appreciate the opportunity, by the way, and welcome everybody. Yes, so Simon Edwards, I've been working in inkjet technology for quite a long time, maybe 20 plus years now. And at Global Inkjet Systems, I'm responsible for product management and business development of our software systems. And a classic example of that is working with partners like Adobe very, very closely to make sure that our technologies are highly integrated and synergistic.
And actually, this is really interesting. We were talking just before we began the webinar. This is really the first kind of public outing of the relationship between GIS, who are known very much in the industrial inkjet space, and Adobe, who of course are known across design in lots of different areas. So it's quite an interesting partnership, which we're going to dig a bit deeper into. But this particular webinar is focused on accelerated deployment and the whole sense that when you're developing a new inkjet system or a new printing application, we know it's complex, and deploying the right sort of solution is one of those challenges. So long lead times can impact on the return on investment. What's the main obstacle to rapid deployment and development? I think this is probably for Simon initially, and I guess the criteria that you see for a successful outcome on a project. Simon.
Yeah, I think it's something I've talked about a lot in the past, and that is the importance of understanding what can go wrong as early as possible. And in particular, I always classify it as two key things. One is about print quality and the other is about performance.
Yep.
And I think one of the dangers of starting a new technology or perhaps developing a new version of a printing machine is to think about getting all your hardware together and simply just trying to build the machine, as opposed to looking very carefully at what's going to cause poor print quality and are you going to be able to achieve the performance you want from the machine you're after. And there's so many factors that are intertwined in print quality and performance, things like the hardware itself, which is where most people look, the inks and fluid systems, and then the software data path. Quite often the data path gets left to the end. Everybody thinks that bit's going to be easy, and admittedly, a relationship, the partnership between us and Adobe, is the whole purpose of that is to make that a lot smoother and quicker. But it is still very important because there's a lot of building blocks we need to put together to make that work.
Yeah.
But print quality, and then part of that print quality is knowing how to measure it. It's one thing about seeing poor print quality or observing good print quality and performance. It's another thing about when things go wrong, how to work out what's wrong. So I think the other key part of that is making sure within your project that you can quickly work out where the errors are by good test patterns, test methodology, really good processes for actually drilling down and working out what the core causes of issues might be. A lot of times we see people get issues with print quality and performance, but they don't know where it's coming from.
Sure.
And so one of the tricks or the keys, I think, for actually really accelerating deployment is having connections to people with the experience that know how to look at these things very quickly and work out, so actually it's this thing over here that's going wrong, or it's this thing over here, or let's see how we can untangle 3 possible things that might be causing the issues.
Yeah. I mean, obviously interesting for people out there is kind of what Adobe are doing in this relationship. And many people will know Adobe from PDF files. And I mean, that PDF files that format has been around for 25 years. Today's printers take it for granted. Young professionals know, it's kind of, they know what it's about. What's the strength, Mark, of the PDF imaging model for what we would term, Simon and I understand to be sort of industrial applications, packaging, industrial. What's the strength there?
Right. Well, the entire printing industry quickly recognized the robustness of the PDF imaging model when Adobe introduced it almost 30 years ago. And it's actually rooted in Adobe's founding product, PostScript, and this picture here is of a young Steve Jobs and the Apple laser writer. So the PDF imaging model was actually initially targeted. The vision was that any content should be viewable and printable on any device. And it was a breakthrough idea, but it was probably targeted more at what was then called the paperless office. But the imaging model was so robust that the graphic arts industry quickly adopted it and recognized that it was the preferred digital format for master files. The content was frozen, it was locked down, and yet at the same time there was some flexibility. If you needed to make a minor price change or something, you had that flexibility. There were other contending formats in the graphic arts at the time, raster-based, Tifit, and others. But the concept of having these graphic objects, which could be maintained at their highest level of abstraction right until final rasterization, was very powerful. For packaging and industrial, packaging, of course, uses a lot of spot colors. And right from the beginning, the imaging model, the PDF imaging model, supported the use of spot colors, mixing them together, overprinting them, and then later on, a few years after the introduction of PDF, blending transparency effects of all the different objects in the file. So the strengths for packaging and industrial are the same essentially as the strengths in the rest of the printing industry, and that is a very efficient workflow, a very robust imaging model, and yet still having some flexibility to make changes and to work with a job.
Okay. Was there another slide?
There was another slide, and it just illustrates the core of PDF, and that is the same as PostScript, that the graphic objects are described as vectors, which means that they could then be scaled to any size and always output at the best resolution of the device. So there's device independence. And that, of course, is critical in inkjet reproduction with its multi-level ink drop sizes and so on.
Yeah, brilliant. Thank you. Simon, I think obviously FuturePrint and GIS have worked together for quite a long time and through our show Industrial Imprint. But for anyone who doesn't know much about GIS, just give us a really quick flavor of who you are, what the origins of GIS are, and your vision of the sort of future of industrial print.
Yeah, sure. So GeoAce is, I guess, on the scale of things, a relatively young company, although we're getting older all the time, as you know. But it was founded in 2006 by Nick Geddes and Jim Broughton. And it was actually started up with a very small amount of capital, about £60,000 of capital. And so it's been a company which has grown on the back of following the market. And that's one of the key things about our business is we follow what people need. And we tend to satiate the appetites of our customers, not completely, but mostly. That's shifted over time, of course, and we are starting to develop more and more core activities. From the early days, we started out with primarily drive electronics. There was a big gap in providing, independent drive electronics for OEMs. A lot of the big printing houses and printing companies, of course, did all their own electronics and tended to dominate the market, HP, Xeroxes, etc. And they were also, totally vertically integrated, doing all their own electronics. But the OEMs, of which there's a lot around the world now, of course, weren't really getting the drive electronics they needed to drive print heads as best they could. And then that kind of rolled over in around 2015 into ink systems. So added on the ink system capability to provide ink systems, and that fitted neatly with our drive electronics because ink systems are intelligent in that they have drive electronics of their own, which have a lot of diagnostics, reporting, and feedback characteristics that we can manage through software. And then, of course, on top of that, we've now layered both of those with a rich software platform, which essentially means we manage the entire data path from, in this case, PDF, all the way down to driving electronics in the ink systems. And our software business is growing quite a lot. So in terms of our business growth, we're growing in all those three areas: ink systems, drive electronics, and software. They're actually starting to balance out a bit more. We're getting a lot more software-only sales. I'll talk about that a bit later, about how, in fact, the new generation of our Atlas platform can actually work with anybody's printing systems. And it also means that the Adobe GIS joint offering is the same. In other words, we can drive lots of different platforms, not just our own electronics. And so from a growth in the market perspective, we're seeing actually like tendrils everywhere at the moment. Some of those mature ones are slowing down, but direct to shape, additive manufacturing, packaging, printing sector, particularly decor, all those sort of main areas which have struggled with print quality and performance. Yeah. Now we're getting that. We're getting much better quality, performance, and control. Are now seeing they can grow properly, and I think that's where it's getting really exciting. Is we're starting to see that the problems they've had historically, and we now have solutions for them.
Yeah. Brilliant. Mark, just coming quickly back to you, just to finish off on the Adobe kind of story. We think often about RIP systems and Adobe RIP systems, particularly with modern pre-press systems. How has Adobe's RIP technology revolutionized the kind of graphics art market? How can you explain a bit? Give us the story.
Well, I touched on PostScript, which was a breakthrough technology at the time. It was one of the contributors to the desktop publishing revolution of the 1980s, along with the Apple Macintosh and
we remember that.
And PageMaker, the first graphic user interface for graphic artists. So the RIP was an essential component of that, and my product, the Adobe PDF print engine, is the Adobe's leading RIP product today. So printing goes to the heart of Adobe. It's built into our DNA. But for example, when PostScript was first invented, we had to develop an application to show what it can do. So Adobe came up with Illustrator, and then a few years later for Acrobat. And what this means for graphic artists and pre-press people in print production is that there is the same core Adobe technology throughout the workflow. Most graphic arts jobs, including especially packaging, actually, and packaging designers mostly use Illustrator. Some use Photoshop. The same core technology that powers the authoring tools is the same technology that's used in Adobe Acrobat, also widely used by pre-press operators and all the stakeholders in the workflow. Is the same technology used in the PDF print engine, and that That fact, and you can jump to the next slide, means that there's a high degree of reliability based on predictability and consistency. And that's critical when you're driving presses, perhaps with variable data at very high speeds. You need that consistency. I'll just mention that just going back to PDF,
Yeah.
Adobe invented the standard, but turned it over to the international standards community in 2008. Pdfx actually was even before that, and that was the first international standard based on PDF, and that's still widely used today as the master format. So that's Adobe's contributions.
Yeah, actually, there was a question, Mark, whilst you're just in that area, talking about Pdfx. Paul Sherfield asked, when will Adobe support the latest versions of Pdfx in CC Suite?
Yeah, I don't have a date for that yet. The spec, as you know, was published just over a year ago, I think around the end of 2020. We have supported all of the all the authoring applications have supported Pdfx 6 or Pdfx, the different X versions. The difference with X6 from previous versions is that it requires some changes, not just to the the export of the PDF itself, but there are some changes needed to be made in the UI. For example, if one of the Pdfx 6 features based on PDF 2.0 is page level output intents. And to basically specify those, you need to associate different color profiles, different output intents to the master pages, let's say in an InDesign job. So it's a little bit more complex than Adobe application support or previous versions of Pdfx.
Okay. Thank you for that, Mark.
Just going to make a comment, actually.
Yeah, go on.
Just to back on something you said earlier about the fact that PDF authoring tools, a large number of the key PDF authoring tools have the Adobe technology inside, as does the print engine. Of course, that's something that obviously attracted GIS to working with Adobe as a standard, because we end up with a standardized approach, and it's all about, as Mark said, it's about predictability and consistency, and that's what we wanted in our PDF server, so that our customers can have that consistency as well embedded within our technologies.
Yeah, Mark, I know you want. There's a couple more slides where you just want to highlight what you see as the kind of crucial strengths of the PDF print engine.
Sure. Yeah. So as we go back, the PDF print engine goes back over about 15 years. We launched at 2006 version 1. Products started appearing in the market the following year. The initial version was targeted at computer to plate imaging, high resolution devices, screened bitmaps. Starting in version 2.0 and 2.5, we added support for the inkjet devices, which are lower resolution but greater bit depth, and then adding support for VDP caching. We initiated the PDF VT standard, which is basically the first VDP standard to take full advantage of the PDF imaging model. We added 16-bit processing, and then you can see that we've got other versions throughout the years. I won't go into any more detail. In the following slides, I'll just call out a few features that I think are core strengths. Yeah. So they're in 4 buckets. I'm not going to go through all of these. Color, exceptional print quality, performance for maximum efficiency, content and context-aware rendering, and other essential tools. So I'll just highlight 3 of those in the next 3 slides.
Cool.
This is a feature called Smart Pixels, where the final raster grid, of course, contains all the color information. I'm showing CMYK here, but of course there could be more. But in addition to these colors, there's 5 additional planes which contain essentially binary switches for every pixel on that surface. And knowing where a pixel originated provides an enormous intelligence to the processing pipeline to do interesting and proprietary things. So if you know whether a pixel is marked or not marked, whether it originated as an image or a vector or a smooth shade, whether it needs to be cached or not, all of that information can be used by the system maker, the product code, to do interesting things, different types of compression, different types of caching, it's a very intelligent additional layer to the actual color information. And then the next slide talks about object tagging, so element-based actions. You can apply different types of conversions or transformations to objects globally. For example, all image objects or all text objects or all graphic objects. But if an operator is able to tag individual elements, you can create a system can create proprietary tags, which can then be used in a proprietary way. And typically you'll need some kind of dedicated authoring tool or a plugin. And there's several out there that can do this from our OEM partners, but also third parties, companies such as OneVision, to add these tags, which can then be interpreted and used at RIP time. The next one is a transparency decision engine. Transparency was introduced by Adobe in version 1.4 just over 20 years ago. It introduced a lot of very attention-getting effects. Graphic artists love to use it, but it can result in some very complex and challenging, and excuse the typo there, I just caught it now, and transparency, but it can be very challenging for a RIP to handle. So a very simple, trivial little change by a designer can result in just exponential explosion of atomic regions. In this, for example, in this object here, you see about 5 or 6 objects, but if you consider their intersection, where they overlap and how they have to be broken down and separately color managed, in this case, you're ending up with about 15, but in this example, you're ending up with about 13,000. So we make a decision, we analyze the transparency elements in a job and make a decision on how best to render it to get the maximum bang for the buck while ensuring that it looks visually good.
Okay.
Yeah.
Thank you for that. Simon, opportunity for you really just to tell us a little bit about the GIS Atlas server and then how the relationship between Adobe and what the Atlas server is doing.
Yeah, sure. Actually, it's really interesting because what Mark's just talking about earlier in terms of the ability to tag objects and extract and, I guess, separate out things from a PDF into buckets of things is quite an important place to go for, because traditionally, of course, screening, you have a screen which you tend to set up, whether it's a amplitude modulated in order to do the screen or the like, you tend to set up a screener for the entire image. Mm-hmm. Things that we're seeing coming through from Adobe enable us to, in fact, screen different components potentially differently and then bring them back together, which is a fairly complex thing to do. Which kind of is a nice segue into what we do at GIS and how it all fits together, because we have the building blocks where we can bring these things and trigger these kind of features quite quickly because of the way we structure our software platforms. Yeah, so from a GIS perspective, we've got I mentioned earlier from history, drive electronics and ink systems. Then we've layered that with our software platforms. And of course, software's been a key component of our drive electronics for a long time. We've got a new generation which has come through over the last 2 or 3 years called our apps platform, which provides even a richer platform and flexible approach to the way in which software works. So it's broken up really into 2 pieces. We have our server-side software on the PC, and we've got our user interfaces. We try to bundle everything into our Atlas server solution, which is not just a RIP. In other words, it doesn't just simply raster the images and process them. There's a lot of more control we've got through that software platform. So we can control all of our drive electronics. We can manage the entire data path. We can extract and display diagnostics for troubleshooting for early stage development, or diagnostics for inline and in-time printing. So you could, for example, if there's something happening on a printing machine, you can see the diagnostics coming through from the Atlas server side. Over time, we're going to start to build artificial intelligence engines in there. Now, we've got some things in there which are intelligent, so to speak. In other words, they look at things and they come up with conclusions about what might be going on. And so the Atlas server is really the heart of, it's like the repository for everything in terms of controlling the print data path and also all the hardware components. Uniquely, the Atlas server has an HTTP interface to it. We went down a path to do that because it is a much more open way of working. So in fact, our customers can interact with the server through an HTTP interface, very much like a web server, but obviously with a lot more, obviously not like a standard web server in that it can do a lot more things beyond just the PC in terms of control. And so we build it in a way which is highly modular, and I'll talk a little bit about that in a minute. The way our interface works is we have an Atlas user interface that comes in two flavors. We have a version which is called Professional, which is designed for building machines, OEM build systems, and the more complex side of managing and configuring and diagnostics. We also have a sort of a alternative view, which is one which can be deployed onto an actual printing machine in a factory. They're both built on exactly the same architecture and software. So they have similar look and feel, but a different way in which they actually interact. One is more PC based and one is slightly more touchscreen based. But fundamentally, they draw on the same platform and base. The UI enables people to do everything from sending an image down, a PDF or a document to be printed, right through to configuring all the systems, through to getting the diagnostics coming back. And going forward, and we'll talk about this in another question that maybe we'll talk about a bit later, when we could dig deeper into print quality and how you manage it, we've got a print quality component now coming out in our next version of the product. So just to give you a bit of an idea, it's a very plug and play concept where the user interface talks to the server itself through HTTP, so you can plug things in the user interface and bring them through. Same with the server side. You can plug and create new capabilities within the app server. And we do that, of course, at GIS all the time, but actually it's open enough that if our customers want to build some components, they can do that too. So we have a software development kit, which allows our customers to add their own unique intellectual property. So if they have a specific thing they'd like to do built into the server, we also support that as a concept so they can build their own components. And a classic example where you can bring all these bits together, you've got a PDF coming in. The output is a printed, say in this case, it might be a varnish going on a pre-printed product. Looks fairly straightforward, but a lot of complexity. And in this particular case, it's a situation where you've got a sheet coming down, which is not necessarily always orientated the way you'd like. And so with the camera system, you can feed that camera system back the coordinates that it captures back into the system. The server can then correct or modify the actual data for the printed image to match each sheet coming down, and then drive the print engine to make sure that, in fact, that varnish perfectly overlays on the object coming through. It's a classic example of how our systems are highly modularized. You can bring all these components together and can actually visually create a data path. You literally drag and drop components on the screen, and then you wire them up and literally draw a line from one to the next. And you can create a data path of how you want to manipulate from the beginning right down to the drive electronics. And to go with that, we also support write to file. So if you want to use the software with the PDF entry point right down to the actual screen data, you can do that to file and do whatever you like with it afterwards. So it's purely a standalone software. You can drive our electronics, but of course, if you can write to file, you can also support third parties. So a lot of these things we've built recently, you can deploy on existing printing platforms and get all the benefits of the print quality performance and the data path performance on existing machines that may not necessarily have global inkjet systems technology built into them. And then even further than that, we've now developed a highly buildable digital front end. So we have our own digital front end for managing the entire job process, and it comes out of the box with an interface that looks like that. But you can also very quickly, within seconds, reshape the entire user interface. We have a tool which allows you to change the color schemes, put your own logos on there, decide what panels you've got or not got. You can even change the way the panels look. They've got sharp edges, they've got round edges, change font sizes. It's a whole range of things. So you can either just use it as it is, as a vanilla flavor, or you can very quickly shape it into your own product. And we think that's very important. It sort of fits the model of what GIS is about, and that is providing our customers with a flexible platform to create their own user interfaces and their own data paths to perfectly match their particular use cases. And that comes back to what we talked about earlier. What makes it quick to get systems developed, and what's the the optimal way of creating technology? Well, it's having a toolkit which is flexible as well. And again, the PDF engine underlies our system, and the way we build it gives our customers that flexibility to very quickly create and shape what they need for their product.
That's interesting. I've got a question that's just come in, but we'll pick that up at the end of this next section. I just want to ask you a bit about print quality. You mentioned it earlier. I always think with the industrial inkjet market, print quality is often really challenging because you're printing on different materials, you're printing on different shapes. There's everything from printing on curved surface. I always think about GIS as one of those pieces of software that really helps you kind of ensure that the print quality is retained. Explain a bit more about that, Simon, so that people get it, if that makes sense. Yeah, I do think it's a challenge for industrial inkjet projects, particularly, isn't it?
I think it's what's really held back some of the big markets, particularly things like single pass flexible fill printing. The holy grail is to be able to match traditional printing machines, which aren't inkjet. And that's a big ask. I mean, they've been developed over 100-something years or so, right? And they have quality which is amazing and highly reliable, but because it's been repeated and learned. And so, when it comes to an analog printing press, it's a well-known art. Trying to match that is incredibly difficult, and that's the expectation. I think that's what's happened. We've all been saying the last 20 years, why hasn't that taken off in some of these markets like packaging? Well, because the expectation is very high. But you can get pretty close now. You can get very close. But some of the issues of print quality are mechanically and hardware driven. They're ink performance driven. The substrates, there's a huge range of substrates people want to use. Traditionally, people are used to using a lot of different substrates. In an inkjet system, every time you change your substrate, you get different drop characteristics on the substrate. So your dot gains change, which affects your color. It affects your image quality. You get, potentially bleeding between dots and between colors. That changes the resolution and the line art fineness. So the whole range of factors. Print heads are pushing the limits of manufacturing. Nozzles are getting incredibly close. Ink chambers have got a lot of intricacy in them, and you get various noises and harmonics through them. So again, the printhead manufacturers are doing an amazing job, by the way. And some of the printheads we're seeing coming through now are exceptional, but nothing's flawless. And I think that's the key. Nothing is flawless. Yeah. So what you need to do is come up with clever methods for managing that potentially in software. And so one of the key challenges of print quality is consistent performance. As I always say, a machine that is performing well and the same way every time is good enough to improve with software corrections. A machine that's not giving you reliable performance is very hard to correct. So it might give okay print quality, but if it's moving around, it's really difficult to correct for. So one of the most important things of getting print quality is actually getting a consistently performing machine. Whether it's consistently performing well may or may not matter depending on where the issues are. Yeah. And there's a lot you can do in the data path to correct for mechanical and machine errors. There's a lot of things you can't correct for, but a lot of these things you can. And I think that's where the state of the art is coming through, particularly with some of the things that we do, is being able to do that. And obviously, ruling out pieces like getting reliable PDF conversion. You want to make sure that's always right, and getting other parts of the system so that you make them perfect is a good focus. Yeah.
Mark, you were nodding your head there. Did you want to make a comment?
No, I was just agreeing with what Simon was saying.
You're enjoying hearing Simon's thoughts.
I learned something every time I listen to Simon speak.
That's good. Simon, just carrying on from that, in terms of job stages, what are the kind of main processing stages for a typical inkjet job? Just take us through it.
Yeah, so once you, I guess what you can't see in the slide is probably the very first thing in this, and that is somehow to make sure you've got a reliable machine that it repeatedly does what you want it to do. You don't end up with things like encoders drifting around, and hence your firing is not right, or you don't want substrate getting poured on a roller, and basically you get jitter at various places, and you're not printing where you think you're printing, and that will cause all sorts of problems. So the first thing is to get rid of all those things.
Yeah.
But probably the first part, which is not on this slide, is a good kit of test patterns to print to see these things. And there's not, I always say a clever test pattern's worth millions. A clever test pattern can show you stuff really quickly. People are probably used to the idea of printing a nozzle out test pattern. That's a fairly trivial thing. But printing a test pattern that shows an encoder jitter or a drift in the substrate across the web or these sorts of things is slightly less trivial. But being able to do that is quite key. So I think the first part is knowing what your system performance roughly is, so that you know that when you go through the path of trying to essentially profile a machine, you know you've got a good chance of getting a profiling that when you apply that, it will be reliable and you'll get the same thing every time. So once you have a machine you think is reliable, then the processes for essentially getting the profiling and print quality is to start off with getting your screeners right. We would traditionally have suggested people spend a lot of time in managing and optimizing and configuring screeners, although we've got tools now which through this path will correct even if you've got perhaps not the most optimal screeners. Needless to say, getting your screeners right is still important. It doesn't take that away. Lots of different screeners you can use. We offer in some of our products up to 10, 15 different screeners. And they're slightly non-trivial, but we can help people set them up and give guidance. The next step is to linearize the channels. That means take a single color channel and essentially print density curves out, match the density curves, and make sure you're actually mapping the density correctly. That's quite an important first step because that's kind of like a bulk linearization of a density mapping for a single channel. Once you've done that, then you want to look at print quality, like channel-to-channel performance, print head performance, print head alignment issues, banding you might get from inconsistencies from the different print heads and nozzles, those sorts of things. So you need to correct that before you start playing with color. And the reason I say that is because the last thing you want to do with trying to do your color management is have to print the same color right across the entire web. So if you're printing, color patches, several thousand color patches, you don't want to have to print every one of those thousand across the entire web to check every single part of it. So you want to get your print quality optimized across all the print heads and then do your color management. So you can in fact print the patches randomly in different places and know that you're going to get the same essential density output. So after you've got your print quality optimized, you can move into your color management. You can start printing out your color patches and get your profiles, do your color profiling, get your ICC profiles right, and then you can start applying them. And then the very last piece of all of that is then when you start to look for poor performing nozzles.
Yeah.
So, missing nozzle compensation. We've got all the tools to do all of this. And so that's kind of like the last piece of the puzzle. And nobody wants a missing nozzle. But in a system, you may not have the luxury of always replacing heads because you've got one or two nozzles missing. But you can definitely, through nozzle compensation, hide the fact that that nozzle is not performing properly to quite a high level. We've seen examples where it's almost indistinguishable, barely see it. Lots of missing nozzles could be a problem. Lots of them together could be a problem. But generally, on the whole, we see that missing nozzle compensation can fix the artifacts until you decide what to do with it, either clean the head, replace the head, or depending on the application, just keep living with it.
Okay. Just before we go to the next slide, there's a question that Roy Reinders has posed, and I think because we're talking about sort of print heads and so forth, he's saying we're currently using several print heads in combination with GIS print server platform. The way he understands it now from what you're saying is that it only applies when using the Atlas server platform from GIS. So just for clarity's sake.
These tools all exist for our USB platform. Just for clarity for the audience, we've got two technology platforms for drive electronics. One's USB based, which essentially is, as it says, USB cable from the PC down to the drive electronics. And then at that end of the electronics, we've got what we call a PMB, which is a print management system, which buffers the data. And then right at the head, we've got a head management board. Right. And that platform uses a software platform called Print Server. So linearization, density corrections, and color management and missing nozzle all exist in that platform. So we have all those tools. It's probably that some of the customers haven't been exposed to it because they may not have needed it from the start and didn't realize it's there. But anybody that is using our USB platform, by all means, contact us and we can help them
Sounds good.
how to do that. In the Atlas server, again, which is now drives primarily our Ethernet platform, which is basically literally as it says, you plug an Ethernet cable between the PC and the drive electronics now. It supports all these things as well. In addition to that, and this is, I guess, something we thought was really important, is that the Atlas server can also talk to our print server rep. In other words, it has the ability to layer on top of our existing USB platform if required. So for security for our customers, what we've done is we're adding lots of clever stuff in what we call our Atlas server, but in a way that it can connect up with our old platform if needed. So we do have customers who have been on our previous USB platform with that software layer who wanted to take advantage of the new Atlas server, and we just layer that on top.
Yep. Sounds good.
So we can use tools in any one of those.
Okay.
places.
Yeah, no, it's got it. Just one additional with that. Rich Brum has just asked the question with so much customizable solutions. How does GIS incorporate functional inks and improve throughput, such as those used in additive manufacturing? Do you want to pick up that now, or do you want to pick up that at the end of the conversation?
We're talking about customized solutions?
Yeah, with so many customized solutions, how does GIS incorporate functional inks and improve throughput, such as those used in additive manufacturing? We can pick that up at the end if you want, Simon.
I can cover it now because what we try to do is, it looks like, from the slides I've shown, it looks like a lot of customized modules, but actually they're core. So we build all the modules in our servers to be as much as possible applicable to all applications where we can. Sometimes we may need to have very bespoke components for certain market applications, which is fine, we can do that. But in general, we still try to make sure that we do it in a way which it can be utilized across all sorts of applications. So most of it, looks like customizable. It's I guess the way I term it is modular rather than customizable. So you can bolt the modules together. We do customized work. And we can do that in two ways. We can either do customized work for customers where they actually contract us to do something specific for them, or we can empower them to do that themselves through our software development kit. It really depends on the skill base of the customer and their inclination, I guess, as to whether they want to do it or they'd like us to do it. And again, we would also look at that and say, actually, is this really a core thing? Is this something we would want to deploy for everybody because it's something that's fundamentally needed, or is it in fact very niche? But we can handle both of those because of the modular approach we've used.
Okay. I know that you wanted to talk a bit about high performance, both Mark and you, Simon. I think there's some slides you want to go to on the look at that.
Yeah, just going to touch on the screener performance just for...
Okay, yeah, sorry, we missed that bit, didn't we?
Yeah, so screener performance is really important, and it comes down again to this idea that Mark and I have been talking about, and we'll talk a bit more about, and that is it's really critical to match performance through the data path. There's no point in having a PDF rep engine that's super duper fast, and then you've got a bottleneck somewhere in the process, because the data path is as good as the bottleneck that exists, basically. So the slowest process will dictate the overall process. So screener performance is quite critical, and we develop both standard amplitude modulated and frequency modulated screeners. So standard what we call error diffusion screeners, but we also develop and have an order dither screener. They both work on different mathematical algorithms. Most people are probably used to error diffusion because you've got a rich selection. There's a lot of different types of error diffusion screeners you can use. Error diffusion screeners are very good to reproduce fine art detail and the likes. Whereas order dither really comes into its own when it comes to performance. Now, arguably, if you take a low resolution, maybe 300 DPI printing system and you use error diffusion compared to order dither, you might see the error diffusion looks slightly better. But when you get up to higher resolution, 600, 1200 DPI, it's actually very difficult to see the difference between an order dither and an error diffusion from a visual perspective. But performance, order dither is significantly faster by a long way. So we have order dither in all our products now. So both our USB and our new Ethernet platform, and hence in our Atlas server platform. And that's quite important. And in fact, it's default. You can change it if you want to choose a different one, but we find that most of our customers use Autodiver and find that the image performance is exceptional. And as I said, most applications, people are moving into higher resolution, so it becomes less of an obvious issue, but it is really important to get the speed of your processing.
So this is a really strong USP for GIS systems, isn't it?
Yeah, correct.
And again,
our screeners is a critical part of our business.
Yeah, and again, coming back to that point about high performance, really, isn't it?
Yep.
Okay.
So I think Mark's going to probably touch next on how that dovetails into the PDF engine, and obviously, how do you get the performance in the PDF engine to match?
Mark,
I'll just briefly touch on a couple of aspects here. Obviously, all modern computer systems are multi-core, and then within each core, multiple threads can be spawned. So parallel processing, you want a RIP that can take full advantage of the available hardware through parallel processing. And the PDF print engine does that for color conversions, for transparency blending, for rendering, and for compression. And as a result, many things are going on simultaneously, and that results in maximum throughput. And this illustration here shows what's going on for us, like within a single instance, let's say, running on a single core, let's say. But if we go to the next slide, we've got a architecture called the Mercury Rep Architecture, which enables multiple instances of the PDF print engine to work in tandem, scaling up to drive the fastest digital press at full speed. And if there is anything to be cached, the cache can be shared across these instances. More importantly than just throwing more instances or more hardware, you don't want to just throw more hardware at a problem. You want to do it as efficiently as possible. For example, it's impossible to predict in advance how long it will take to rip any given surface. And that's just because of the complexities of vector mathematics. So it's if you have a multi-instance system, it's quite possible to have one instance sitting idle while there's a big backup queue for the next instance, because you can't just divide a job up, let's say a multi-page job, and divide it among all the available instances. You have to keep track of when the instances become free and dynamically allocate them accordingly. So that's the Mercury Rep architecture. And then the next slide illustrates this concept of tiled parallel processing, which is kind of the same idea as the Mercury Rep architecture. In fact, it builds on the Mercury Rep architecture. But in this case, each instance is not handling a separate page or a separate surface. A single surface, a large surface, let's say a billboard or a large map, can be subdivided. And then each tile, let's call it, allocated to one of these instances where it is ripped, and then seamlessly brought back together. In other words, there's no artifacts at the boundaries. So this is very valuable, especially for large sizes.
Interesting.
So
Okay. Just going on from that, when you're kind of color management, and obviously modern color management sort of based on device profiling, getting it right, color fidelity, but there's some challenges. So how do you deal with handle those challenges that you get feeding into an inkjet press? Simon?
Yeah, color management is a tricky thing. I guess one of the things I mentioned, as I said before, of course, is machine stability is critical. Because you can get the color corrected and then it will drift if you don't have a stable system. And then, of course, the other thing is if you change something, if you change the, anything in a print mode, for example, you might, obviously resolution will have an impact. The screenage you choose, how many bits per pixel you use, all these things. In fact, there's a myriad of things. If you change slightly, it will affect your color result. And so it's pretty critical that in your color management that you know what your use case is and how it's mostly going to be used. And then when you go ahead and try to do your color management processes, that you have everything tied down to a certain, as much as you possibly can. We've seen a lot of cases where people get color management and they get a result, and then, they print for half an hour and they get drifts because the ink is changing, the dynamics are changing in some way, the system's heating up, or the ink pressures start to move because there's something, the way that they've done something within the system.
Is that also, you've got two sides of it? You've got this kind of hardware side and the software side, haven't you? So that, machine stability. And
most of the stability, of course, is on the hardware side. Hardware being mechanics and fluids. Is the very obvious one. Of course, substrate's another key one. And we see, for example, particularly things like tubes, plastic films, non-porous substrates. You'll see drifting in performance depending on the surface energy. And that's quite a key one, is that, the surface energy of material will change over time. And often things like plastic tubes and films are pre-treated. But in a analog system, they tend to be more forgiving to surface energy issues because they're obviously, a lot of them are pressure based, so it's actually been pressed up against the substrate. So you can get that, you can hold it there in the nip for a certain reasonable amount of time. But an inkjet system is less forgiving. So if the surface energy is moving, the drop formation may change. And the drop formation, a change of 10 to 20% in the drop size when the volume's the same, but the way at which it wets out on the substrate, or if it's more hydrophobic, then it might not wet out as much, will affect things like color and areas of the substrate. So it's interesting because you need to get that right. And then you've got to have all the right toolkit. I mean, I think the mechanics of color management have kind of been well tuned now. There's a lot of people offering color management toolkits and software to do the color management side.
Mark, did you want to add anything on the sort of software side, on the systems?
Yeah, sure. But I just want to, I really like Simon's point about all the interdependencies and how small changes in one of many factors can, everything's got to be tuned. And I can understand, we're not talking about, we're talking about where ink meets paper, where rubber hits the road. It's not, just like a purely digital process. And that's the challenge. Now, from the Adobe side, Adobe has a long history in color management. We have many color scientists working across the company. Actually, you could even say that we made a stab at color management even in the days of PostScript with the color rendering dictionaries. So this is a foundational technology for all Adobe products, one of our core strengths. The PDF print engine ships with the Adobe Color Engine, the same color management module used by Adobe applications such as Illustrator, Photoshop, InDesign, and Acrobat. Our partners also have the option of using their own proprietary or third-party color management. And it handles process and extended color gamut ink sets and emulating spot colors, separating plates, and so on. And I just have one more slide here on transparency blending, which I touched on earlier. This can be very complex. There are 16 different blend modes when you stack objects on top of each other, which have different degrees of opacity. You need to be able to combine them all together. And some of these blend modes are very mathematically challenging, let's say. So that's all part of the color management module and transparency in the Adobe PDF print engine.
Thank you. Simon, did you want to add anything to that? Or
no, I don't think so. I think it is important to make sure, one of the things is it's actually it's a really easy word to use, color management. It's a really short two words in reality. But the truth is color management is really quite complex. There's so many elements of things coming in from a PDF and so many things relating to how do you map the colors, spot colors, process colors, mapping those across properly, where do the profiles fit in? You've got different profiles for different elements. It's actually quite a complex thing. Unpicking all of that, having something like the Adobe PDF sitting there to do that for us and where we can apply the profiles is great. But as I said, it's a complex thing that on the surface it looks straightforward to most people, but then when you dig deeper, there is a lot of mathematical and complexity in it. And it's, that's, I guess, one of the things that we try to bring together as a group is the ability to unpick that and make it as clear as possible to our customers.
Yeah, and talking about that sort of thing, just to finish off, I asked the question a bit about variable data, because this, it's a challenging one. Oh, here we go. So this is good. So just generally, if you could just describe, a typical scenario to illustrate the challenges that people might face in terms of data and managing it on different materials and things.
Yeah. The big challenge of variable data printing is compositing together unique variable elements with repeating elements, and the repeating elements need to be cached so that you're not continually reprocessing them. So in the area of packaging and industrial printing, the variations are typically serialization, so serial numbers or serial barcodes, and these can be used for track and trace or authentication. The PDFBT standard has a hint to explicitly declare whether an element is cache worthy or not, and this accelerates runtime. The PDF print engine, even without these hints, can make a decision on what to cache, and we have different types of caching. So this is a key strength for driving, variable data at full speed. And I'll just mention one more feature in the next slide to quickly move on, and that is the subject of transparency. Transparency, of course, must be blended together, and retrieving and storing and caching transparent elements is one of the core strengths of the PDF print engine in variable data print jobs.
Sure. Gents, we're kind of coming to the end of our time. We've got we've got two questions. I'm going to fire these off to you before we wrap up. Rich, again, has asked the question, probably aimed at both of you. Is it fair to say that there is the ability through software from GIS and Adobe that gives customers the best inks or ink supplier to choose, or is that independent to the customer?
So the question is about ink supply?
Yeah, I think what he's saying is it fair to say that the ability through software from GIS, so your software gives the customer the best inks or ink supplier to choose, or is that an independent to the customer?
I'm not quite sure I know the question, but I can provide comment about the ink side of it, which probably covers that. Is that
go on, far away.
So we, at GIS, from a software toolkit point of view, we provide all the tools to be able to optimize things like waveforms and ink management systems, and how you maximize and optimize the ink fluid mechanics and the electronics of the ink fluid system. So we provide all the tools to make sure you can optimize your inks. We don't necessarily do that for customers. In other words, we don't take an ink from a supplier and we create the best solution and deploy a waveform to them and all these parameters. We just tend to provide the tools to do it. We've certainly, because we've been in the industry for such a long time, we certainly know what the right things to do are, and we can give people some pointers as to what are some of the best configurations. But generally, when it comes to, for example, optimizing inks and getting the right inks, we tend to get them, the ink suppliers tend to do that directly.
I was going to say, but you also work quite closely with ink suppliers, don't you? So
we try to work closely with everybody.
Yeah, sure.
So ink manufacturers, of course, will have our kit. So that they can do optimization and development on behalf of our customers and what is essentially their customers.
Yeah, because often the ink suppliers always complain, don't they, that last thing on an industrial inkjet project is the ink, and they're always forgotten until the end. But so working with you, but that idea that you've worked with a number of them. So if anyone's thinking specifically about that, then the conversation, you probably need to have a conversation with you, and you'll advise them whether how the relationship between the software and the ink will work.
Yeah, we've got a lot of knowledge around it.
Yeah,
and we're happy to work with our customers to provide advice on all sorts of things. But at the end of the day, that then obviously needs to get back to the ink manufacturer where they interact with them. But
I think we got the answer there. Rich has just commented saying thanks very much, gents. I think that's right. Okay, quick question for Adobe. So do Adobe plan TP add tools to add hints to Illustrator or InDesign and add VDP tools in general?
So InDesign has a VDP tool today called Data Merge. It's available as part of InDesign Server. And also people want to check out the cloud-based version of Data Merge. They can go to aspen.adobe.com. Illustrator, it's also possible to create variable data print jobs. I will agree with the questioner, or the implied in the question, that there is certainly room for improvement in these tools. And they
Did
do
you sense
today.
that from that question?
They do not insert any of those hints. We are working with those product teams to. Yes, I knew it was to, not TP, as Fraser, as you read it, as you read the question. But yeah, so that so I will mention those, and we also have a third-party ecosystem for variable data printing. Exchange is our marketplace, if you will, for these plugins to InDesign, Illustrator, Photoshop, Acrobat, and other tools. And we do encourage our partners our ecosystem partners in this space, people to check out some of those products.
Cool. Well, thank you for that. Simon, just one quick question. There's a question here, which I think is basically hinting at whether, well, I'll ask the question, then I think we can work it out. Is this inkjet system able to replace pad printing? Are the inks suitable to be printed on ed-coated material or metal surface? Just so, I don't think that's exactly what he's meaning, but perhaps you can just explain, in terms of inkjet and pad print, does your software work on inkjet systems that are kind of replicating what a pad printer would do?
Yeah, pad printers typically use really highly viscous inks, and they result in prints which have got quite a surface relief to them. You know, they are very thick. So the question really relates to, are there inkjet heads that can print high viscosities?
Yeah.
Which is probably the main. And yes,
and I think he's talking about bike components as well. I'm not sure whether it's motorbike or bicycle components, but exactly as you said, it's probably very detailed components, aren't they?
Yeah, kind of a two-pronged issue. One is pad printing on bicycles is quite common to get really nice branding on the bicycle. So it's quite a heavy ink, and it's on a curved surface. You can print onto curved surfaces. You know, one of the things we're looking at, and it's one of our things we've been developing. It's been kind of in its infancy, but we have a lot of the key components is direct-to-shape printing using robotics.
Yeah, you've been doing that quite a long time, though, haven't you? I mean, the software for direct-to-shape has been there for a long time.
Yeah, so we've got the software. We understand the software. We've got software components. It really comes down to robotic control and, you know, basically matching print heads with application. This is a good example. Printing onto a bike component with very highly viscous inks. There's a combination of a print head that can handle high viscosities. And there are there's a lot of technology coming out in print heads now. I think it's fair to say, in fact, the last 12 months, we've seen more new stuff coming out with new print heads than we had for the 12 to 24 months before.
Sure.
Highly viscous, large drop and high viscosity print heads are coming out. Whether you can achieve exactly the same decoration as a pad printer is questionable, but possible.
Yeah. I mean, that, to be honest with you, that's been a question for quite a long time, hasn't it? Because, you know, the traditional, when inkjet into industrial applications started, it really, you know, it was traditionally sort of where screen had been, and obviously pad is another one that's on curved surface. Exactly, you said it's sort of like handcrafted printing, if that makes sense. It's been challenged. Inkjet's challenged by that, isn't it? Because it's really it's difficult. It is difficult.
But we'll see flow through. You know, the automotive industry is all over.
Yeah.
It's this, you know, in terms of robotic
precision and robotics. That's
printing. Right. So things like printing bike components and all those sorts of things, we'll see the benefit of that kind of robotic direct-to-shape application that's coming through over the next few years.
That's interesting. Gents, we really come to the end of this hour. I've had some nice comments about both of you in the chat, which is great news. Very informed, very interesting. I guess that if anyone's interested to know more from either of you, then obviously you'll make contact with the people that have been in the webinar, and obviously you can get an email directly if you want to get in contact with either of the gentlemen that are speaking. Gents, just final question. Is there anything you want to say about the partnership? Any final comment? You kind of suggested what do you bring to the table. I want to just hear whether you think there's one final comment about this partnership that's really worth people knowing.
Well, from my perspective, the Adobe team are professional, accurate. Basically, the team themselves are consistent to the message about their product, which I think is important, consistent, reliable. And I think that's been a philosophy of ours. So I think there's two things here between this partnership. One is the technical partnership of what we're delivering and the performance matching, but there's also the organizational partnership, because that makes a huge difference. And it comes back to your very first question: what makes a project get where it's going quickly? It's a partnership of people that work together well, and that's been something that's been quite pivotal to this one.
Brilliant. Mark, final comment from you.
Yeah, just the depth of experience from Adobe and GIS, the institutional knowledge in our respective fields, coming together, I think makes a very strong combination for vendors and OEM manufacturers seeking to accelerate deployment of their systems for industrial printing.
Brilliant. Gentlemen, thank you very much. If you've enjoyed this session, then obviously always look to futureprint.tech. We're always hoping to bring to the marketplace interesting, informative sessions like this. We've had two great speakers today, but thank you very much, gents. Really appreciate that. And let's hope we catch up in real life fairly soon. Thank you.
Very good. Thank you, Fraser.